Welcome folks, quick video here to address a concept that was introduced right at the end of the previous set of tasks that you completed, the dew point. What's this thing all about? Why is it a useful idea? So I want to actually share with you some weather information that I'm actually looking at right now. I'm recording this video on January 10th. It is 2021. Here are some weather conditions that currently exist for right now. It is 29 degrees Fahrenheit outside. The other sort of classic bits of information that you usually get if you look up the weather is oftentimes relative humidity. So relative humidity is 69%. That might seem kind of high to you, but remember, cold air like this can't actually hold very much water in it. So really the air outside is pretty dry. I mean, it's can't really get all that much more humid than it already is. It's dry just because it's pretty cold. Now, the other thing that oftentimes gets reported here is what's often called the dew point temperature. For today, right now, it's listed as 20 degrees Fahrenheit. Now, worth noting is really when you look up the weather, you'll almost never see a representation of absolute humidity in the same way that I've been presenting it to you. Like, you're not going to see it as what percentage of the air is water. Instead, you get this. So it turns out that this dew point temperature idea is actually one way to talk about and measure absolute humidity. It's a little bit of a harder one to conceptualize, but that really is where it comes from, and I'm going to try to explain to you how that's the case. Okay, there's lots of different ways to define the dew point temperature, but here's one way that fits pretty nicely with what we've been describing so far. It's essentially this idea: if you cool the air to this temperature, then you're going to be at 100% relative humidity, which means the water is going to start coming out of the air at this temperature. Notice how that reflects what's going on up here. Okay, right now it's 29 degrees and 69% relative humidity. If I cool that air down, I am not changing the amount of water in the air by cooling it down. I'm not changing that at all. The only thing I'm changing is I'm changing how much water could be held in the air at any given time. Because remember, colder air can't hold as much water. So as I cool this air down from 29 degrees Fahrenheit to 20 degrees Fahrenheit, my relative humidity goes up until eventually it hits 100%. Basically, we have as much water in the air as we could possibly hold based on the temperature. Water is going to start coming out of the air. You're going to start forming dew, or actually in this case, we're going to get frost to form. Why? Because it's going to be at 20 degrees Fahrenheit if you get it all the way down to that temperature. So why is this actually a measure of absolute humidity? Well, think about it this way. This right here is the central idea. The point is, if your dew point is really low, if it's a really low temperature, I mean, let's say if it's even lower than 20 degrees Fahrenheit, let's say if it's like 0 degrees Fahrenheit, there must not be much water in the air at all because, again, think about what you're trying to convey by the dew point temperature. It's the temperature at which you'd have to get it that cold before the water starts coming out of the air. Remember, cold air doesn't hold very much water, and the colder you get it, the less water it holds. If your dew point is really low, you must have incredibly dry air because you'd have to cool that air down a heck of a lot before you start getting condensation to form, either as dew or, in this case, frost. So for today, this is a pretty low dew point temperature, but it's not as low as it can go. So just to give you a couple little benchmarks here, and this, of course, depends where you live in the world. I'm talking about what's going on here in New England. Winter air is dry. Why? Dew points are often going to be sitting around, well, 20 degrees Fahrenheit or less even, if the air is even drier than a day like today. Summer air, in contrast, is going to be way wetter because those dew points could be 50 degrees or higher in some cases. And again, it depends where you are in the world. There are some really muggy parts of the world where the dew points could be pushing 60, 70 degrees. That is oppressive. That is like the air becomes kind of thick. You can feel it physically. But again, this idea of the dew point, again, is related to a notion of absolute humidity. It doesn't tell you what percent of the air is water. It gives you a different way to think about absolute humidity, and it is actually a pretty useful idea and a useful concept. So we're going to be using this idea quite a bit going forward. These are the core ideas you got to know.